So first off, just want to say thank you everyone for joining. Today we're talking about the Creo Advanced Assembly Extension. And I just want to tell you a little bit about Elite. We are a PTC partner, which means that we are authorized to resell their software and provide services that go along with it. So just kind of a very quick overview of what that entails. So you can see the product lines down at the bottom. Today we'll be talking about Creo, specifically the Advanced Assembly Extension and how that's useful for especially larger assembly. Works particularly well with those and helps you to do efficient design and really design concurrently with other people as well. And also wanted to mention that until the end of this year, or just about, there is a pretty substantial discount on the extension. So if you are interested, I do encourage you to act quickly because 32% is a pretty substantial number. It's more than I usually see. So again, here is my contact information. Feel free to reach out to me, and I'll send out this WebEx as well. So everyone can answer, get any questions answered as well. That being said, I'll stop sharing my screen. And I'd like to introduce Emily Pinto, who is with the Virtual Center of Excellence at PTC, who's going to be showing us what the Advanced Assembly Extension looks like.
Hi, everyone. Thanks, Stuart. Thanks, everyone, for joining. So I work in the Virtual Center of Excellence. As Stuart said, we're a group that specializes in giving high-level overview demonstrations of all of our solutions. So I work in the CAD area, and today we're going to talk about Advanced Assembly Extension, or AAX, if you've seen the abbreviation. So before we jump into it, let's talk about why PTC created this product, this tool. And it's because time-consuming concurrent design processes are really difficult to manage, especially with complicated assemblies. So it can be difficult to manage distributed design teams. You can lose productivity and efficiency due to poor communication, errors, rework, people creating the same geometry, twice, or waiting for someone else to finish their part of the project before they start theirs because they need their surfaces. It can also be difficult to secure and protect company IP. A lot of times this concurrent design and collaboration, especially on big assemblies, it happens with people outside the company. So you want to be able to protect that data that you have while still being able to collaborate with other groups. There are limited tools to support these. So PTC really saw a need for an advanced assembly extension that has these capabilities because it's difficult to define assembly structure and enforce top-down design and manage assembly performance with the tools that are traditionally found in CAD solutions. This is a whole new type of management and a system of working. Usually the CAD system is built, you create the sketch, you make the part, and then you assemble all of your parts into an assembly. You can assemble your sub-assembly into the big one. But top-down design, the way to manage large assemblies and to manage concurrent design is top-down design, and that's the complete, backwards flow. So you need tools to be able to do this because it's something that you need a specialty system for. It can also be slow and tedious to design this assembly process planning and documentation. So it's a very complex process to communicate the requirements, integrate data from design partners, and create all of this process planning documentation. So that was something that we needed to make sure was included as well as part of the spread of capabilities that Advanced Assembly was going to cover. And so our solution, the Creo Advanced Assembly Extension, provides all those tools that can help speed assembly design and streamline the flow of information from design to manufacturing. So these capabilities enable companies to effectively manage the assembly process and reach that optimal design in less time. So the specialized capabilities, the tools that this provides for you are tools to, one, manage top-down design assembly process, support design and build-to-order initiatives, manage assembly performance, and automate the creation of assembly process planning documentation. So let's take a look at some of those capabilities. Our top-down design capabilities, this is primarily done using skeleton models. So the skeleton model is the outline or the framework of your assembly. So you lay out your assembly where everything's going to go. You create curves, lines, surfaces, points, planes that are necessary for that top-down design, that are necessary for your assembly, and you define their locations and their geometry, first thing in the process, and then you can build all of your parts and geometry off of those. So that's the skeleton model. And it can also define motion skeletons to support mechanism design and evaluation. And then at that point, you can distribute this data to establish design criteria and support concurrent development. So you're going to share these lines and curves and surfaces with whatever group might need them to start building their parts, to start building their geometry. That way you can control the references and control the shape. So we also have a reference viewer. You can graphically visualize dependencies and relations to understand change propagation. So a really great way about the top-down design is that you can manage, what's being referenced so that if you need to make changes later, you can make really big, high-level assembly changes, and all of your parts and everything are going to update. So this is part of that, being able to understand where your references are and who's using what. And of course, this is around reference control, so define best practices to manage and limit those assembly component references. So this is all going to come with that top-down design and supported through the skeleton model and these reference viewers. We also have concurrent design support, and this is really done through data sharing. So you're going to be able to define and publish the contact interfaces between the subassemblies and components. So this is done, up at that top-level skeleton model, and then you're going to be able to communicate those lines and arcs and surfaces and share that reference geometry with the extended design team as they need it. So this is going to eliminate unwanted dependencies and references. Of course, then we have inheritance models. So this is maybe something new. You're going to be able to define a model to provide one-way associative propagation to derivative parts. So if you want to make sure that changes made at the assembly level are propagated through all of your sub-assemblies, that's something that you can do, of course. But if you want to stop that inheritance from going the other direction, if you have a part that you need to make changes to, but you don't want to push that to the top-level assembly, you're going to be able to do that and control which gets pushed which way using the inheritance model. So you can support concurrent development of those downstream deliverables that reference those. Assembly configuration, we have interchange groups, so you can support configure and build to order initiatives using functional interchange groups. You can also define design logic and rules to support the rapid creation of custom product variants. So if you define the reference tags to automate assembly, define configuration rules, enable reference forwarding. You also have design to order. So define simple programs to automate product line customization, leveraging input parameters. So you're going to be able to drive the creation of a configurable product from spreadsheets, layout tables, and programs. Our assembly process planning, so automate the creation of assembly process plans and manufacturing documentation. This is a big time saver. You're going to be able to generate associative manufacturing bill of materials for each assembly step, and then publish the assembly process plans for web delivery. So this can all be automated and use all of that information and geometry that you used in your assembly to create these process planning documents. We also have visualization and performance management. You can utilize these different types of skeletons that you have to define functional subsystems and work effectively with large data sets. So now that you are able to use the skeleton model to push just the needed curves and surfaces into the subassembly that's going to reference them, now that subassembly, whoever's working on it, doesn't need to open up the whole train car in this example to be able to see what they need to see. So you're going to be able to have open smaller subassemblies while still including all of the geometry that you need to reference, that you need to see. And you can set those custom. You can custom set all of your different reference views or do them according to your model tree. You can also use external shrink wrap geometry to reduce load time and increase system performance. So your shrink wrap is just going to be a lightweight representation of whatever you want to include. We can move now into a demonstration. So we're going to look here at, we have our Creo window. We're going to look at a train assembly. So this is a large assembly, and anything that any large assembly should be covered under this train assembly because there are a lot of parts. There's a lot of stuff going on. And first, we're going to look at our skeleton model, our skeleton part. So here we can see all of these curves and surfaces have been defined at the top level. And in order to share those to support concurrent design, we're going to select them into groups. So we call these groups published geometry. You can publish different groups of geometry. And then you can name them to be able to share them very easily. So we've selected a couple of lines and curves and planes that is going to be useful for the structure design. We also have someone else working on the interior design, and they need different lines and surfaces, but they need to be able to reference them so that everything fits together, in the end, and we're controlling those references. So here we're just going to select the geometry that they need, that group is going to need to build out all of the parts that are in the interior. So we're going to publish that group and call it for interior. And now when we go over to our model tree, we can copy geometry into the subassembly. So if you heard of copy geometry before, this is where it comes from. This is the reason that this is necessary. So we're just going to copy that published geometry that we had. We're going to say put that group of references that we've copied from our skeleton model and add it to our subassembly. We're going to do the same thing for interior. We're just going to copy the for interior published geometry into the interior subassembly. And now, like I said, whoever opens that for interior subassembly doesn't have to have the whole train open, doesn't even have to have the whole skeleton model open. They can just use the references that have been added to their group. So it gives you a lot of data control over how your groups are working and what they're referencing. Of course, we can look at individual assemblies. So here we're looking at our structure assembly. And we can see these lines and curves that have been added from the skeleton model. And then now we're just going to do our regular, Creo work. So instead of creating, according to, dimensions or waiting for someone to be done the outside of the exterior of the train, we're going to be able to design this structure right away. So we can use those actual lines and curves that have been shared with us. No need to duplicate work. Someone at the top level has already made these. We can just use those right off the bat to create the geometry that we need to. And of course, this is just your regular Creo process. So, whatever this engineer might need to do in this assembly to build it out, they can continue doing. So that we're just going to create an instance of that window of the, structure of the arch. And then when we go back to our top level, you'll see we have a lot of different ways to view this top level because there is so much geometry. So we have a couple different representations. We're going to look at the master representation. What this does is it pulls in anything that's been done. So we're just going to look at the full view of that. Moving into our interior model. Here we can see we've already, we see the reference lines and surfaces already. And we can use those to start building. So concurrent design is really easy. We're going to use those as references. We're going to create, we're going to project it onto our geometry. We're going to go ahead and start working right away. We're creating our window. We're just going to create a lip for it. So we're using that sheet metal geometry, that sheet metal capability that we have inside Creo. And we can set all of our options. Again, this is, concurrent design. So at the same time we're doing this, somebody else could be working on that structure. Maybe this window isn't even built out yet. That's in a different assembly. But it doesn't matter because we can get on with what we need to build using all of that top level down design strategy. We can show the full assembly here. And then when we go back up to that top level, we can control the view. So if we want to see, okay, well, what has the interior team been working on so far? Let's look at that master representation and see all of the geometry they've created. You'll notice it all fits right in. So just making one more change. we're going to look at the door here. So what we've done, we're just going to update this shrink wrap. What that means is that we have a shrink wrap full of parts that are relevant to this part of the model, to this feature. So what we're going to do is update that shrink wrap if things have been added or things have been removed or changed. It's all going to update so that we know we're referencing the most recent geometry. And this is a lightweight representation. So all of this geometry that we saw pop in with the shrink wrap, that's just a lightweight representation. So it shouldn't make our model cumbersome to work with. So what we're doing here is we're going to set the copy geometry update to manual. And what that means is, as I said earlier, because we set all of these references at the top level in that skeleton model, we can make changes to that skeleton model, and it'll update, make that change to all of the parts that are referencing it. But if we have critical parts that we don't want to automatically update because maybe that update causes a problem, we want to double check manually that change is appropriate for that part. So we can set it to manual. So we've set this door to manual, which means if we update anything that it references, we update these reference lines and curves, we're going to get an alert and we're going to be able to manually take a look at this to make sure that that's an update that we want to do. So we'll see that a little bit later. But here we're just going to build out our door, build out the windows, cut those through. Again, this is just your regular Creo work. The advanced assembly is a way of organizing and managing, but all of the regular Creo details are, that happen in all of those sub-assemblies and different design teams, those are all going to stay the same. Everything's going to be the same. It'll just be easier. So we're going to show all of this. We're going to come back up to our top level again. We can bring in that master representation again to see the door. And then we're just going to have everything up to date. So we can see there, and it says master rep next to it as it shows that master representation. So we can see exactly what type of view we're looking at. But now we're going to go on to the next step. We're going to make a change and see how this is managed. We're going to open a design exploration session to do this. So this isn't necessary. A design exploration session is a tool for managing different versions of your model. So this is another Creo extension, and we're going to open a session to get this checkpoint tree. And what that means is that we have kind of a sandbox environment where we can make changes to our model with no risk of losing the original, with a really great system for organizing all of the different steps and changes that we made. So at any point, if we make changes and we like the changes, we can save it as a checkpoint, toggle between them all, see different versions, different ideas we've had, branch off of earlier ideas, stuff like that. So the change that we're going to make here is to our skeleton model. So we're going to make a change, a big structural change. And there are a lot of parts dependent on this outline. We're going to bring that bottom in just a little bit. So when we regenerate, you can see it's regenerating all of the features that reference the lines that have just been changed. So because we shared that data and we're using all of the same lines for all of our geometry, our model is very, very flexible. We're able to make updates and changes very easily. As you see, we have this notification that there's one feature that didn't update. Well, that's because we set it to manual. So this is a really great way to keep an eye on all of those critical pieces that you want to make sure don't get accidentally updated to something that really isn't optimal. So now we can go in individually. We can use this tool that we can see actually the differences either in context of the assembly or by itself. We can see the outdated and the changed version. And then we can choose to update or to revert that original change we made. So we like this new outline, this new exterior. We're going to add that as a checkpoint here so that we can revisit this if we make changes down the line. We can always come back here and go in a different direction or whatever way our design process takes us. We're going to open up a section view inside of the train, and we can see here that we have a chair. We're going to make a change to this armrest just to demonstrate what some of the change capabilities are here and with the design exploration. So we want to create a support for this armrest. Well, that's very easy to do. Again, just your regular Creo work. And if we push that up to suppress it, we're going to look at the View Changes menu that we have. So here we can see the history of the changes to this piece. So we can see the model graphics. We can also see the model tree, and there's a legend down at the bottom to say this was renamed, this was modified. So you can really understand the history of that part. If we like that change, we can say, okay, save that as a checkpoint too. Maybe I want to bring it up in a design review. And of course, if this has been copied or repeated, it's going to update other features. The way that the design exploration works is we can activate any of these points to see what the differences are. And then we can push those to our master copy if we like the changes. So we can say, okay, this is the checkpoint that I want to take forward in my design, and accept those. You can also exit and not save your changes, at which point you're brought right back to the model that you went in with no risk of accidentally forgetting a change, or forgetting to undo something that you didn't like. And then you can also save the session to come back to later, open those checkpoints up in a design review, toggle between them. Again, that is a separate extension from the advanced assembly, but they work really well together, being able to investigate all of these different changes and structures. So one of our tools here is this view manager. We're going to open up this view that we named Demo Finish, which is just the end of the demo. But you can see we also have the default rep, master rep, automatic, the standard ones. If you have a certain selection of sub-assemblies that you want to see over and over again, you want to check in on, if you have a certain type of view that you want to see, this is where you would save that. So you could save all of the different views that might be useful to you in your complex assembly, be able to understand exactly what's going on, and then communicate that with the rest of the team. So circling back, just to summarize what we saw today, our customers who have adopted advanced assembly into their design process, who use this tool, we get feedback from them on how it's helped their design process. And what we hear is that it's reduced the time to market and costs. This is really going to streamline that assembly planning process. It's going to streamline all of the concurrent design work and reduce errors and rework and copied, duplicate work. This is also going to help you increase product quality and innovation. You have a lot of control over your whole model. It's flexible. You're able to make changes easily. You're able to see and understand exactly what's going on, control the references, control all of the geometry that's being used to make up this this complex assembly. Develop and define new markets. This really allows you to open things up and develop where you see fit. And Stuart, that's all I had to share today, so I can pass it back over to you.